external obsolescence.
No, external economic obsolescence. External obsolescence is diminished utility of an improvement due to negative influences emanating from outside the building and usually classified as incurable. External obsolescence can be caused by many different factors. Market comparisons similar to those used to estimate incurable functional obsolescence can also be used to measure external obsolescence. The capitalization of a rent loss is handled in a fashion similar to that used for incurable functional obsolescence. Because external obsolescence affects the total property, improvement, and land, the obsolescence attributable to the improvement must be isolated. The site value, if correctly estimated, includes the external obsolescence factors affecting it. Therefore, the appraiser must be careful not to penalize the land twice. The following are several methods of measuring external obsolescence: capitalizing the income or rent loss attributable to the negative influence, comparing comparable sales of similar properties, some exposed to the negative influence with others that are not, and allocating market-extracted depreciation. If verified sales data are sufficient, the last method is preferable. However, when appraisers attempt to account for differences between the subject property and the comparable properties, significant practical problems can occur. The following is an example of measuring external obsolescence by capitalizing the income rent loss attributable to the negative influence. Assume that a single-family residence in an area zoned for residential use is being appraised. A special permit has been issued, and a gasoline service station is constructed on the adjoining property. The marketability of the residence is adversely affected. An analysis of similar residences reveals that $1,200 per month of typical rent is typical rent. This adverse condition limits rent of the subject property to $1,100 per month. Market analysis further reveals that similar residences in this area typically sell for 120 times the monthly rent. The monthly GRM is 120. The land improvement ratio is 1:4. Therefore, the amount of external obsolescence is $12,000, of which $9,600, 80% of $12,000, is due to the improvements. The balance, $2,400, should be reflected in the site valuation. This method is typically used for appraisals of single-family residential properties. The calculation of external obsolescence income rent loss is as follows. Estimated monthly rent of subject property is unaffected, $1,200. Estimated monthly rent of subject affected property, $1,100. Estimated monthly rent loss, $100. Estimated total rent loss is to property, $100 times 120, which is the GRM, to equal $12,000. Ratio of land to improvement is equal to 1:4. Land is equal to 20%, 1 divided by 5. Improvement is equal to 80%, 4 divided by 5. And your extra that 80% is multiplied
by 12,000.
By the 12,000, which the external obsolescence is $9,600. Oh, okay. Yeah, I see that. Okay. For other types of property, such as commercial and industrial, the loss in annual income is divided by the building capitalization rate to determine the value loss due to external obsolescence. For example, the subject property is an office complex adjacent to a paper mill. On windy days, the neighborhood and the subject property experience a strong offensive odor. Office complexes a few blocks away from the subject property do not suffer from this odor. An analysis of NOI for these comparable complexes indicates that the subject improvement suffers an annual income loss of $20,000 due to the influence of the paper mill. The band of investment method of developing the capitalization rate shows the building capitalization rate is 8.0% as follows. Estimated loss of annual income from external influences on subject improvements, $10,000. Building capitalization rate from the income approach is 0.08. Income loss divided by the building capitalization rate, $125,000. Did I read that wrong? I think I read that wrong.
No, you didn't read it wrong. They printed it wrong. Because in the text above, it says analysis of the net operating income for these comparable complexes indicates the subject improvement suffers an annual loss of $20,000 due to the influence of the paper mill. And that first line says estimated loss of annual income from external influences on the subject is $10,000. So they say 20 up here, but 10,000 down here. I don't know what the hell are they doing. Crazy people.
You said a bad word.
Okay, well go ahead.
Well, income loss divided by the building capitalization rate, external obsolescence of improvement.
Basically, your estimated loss of income is multiplied by the capitalization rate from the income approach, says, which they'll probably give on a problem.
Test.
They typically give that capitalization rate or make you find it on the schedule.
Yeah.
But then you multiply that. Let me pause this and run the number.
For the example on the bottom of page 292, something doesn't add up. Something doesn't work with the example that's given and the numbers that are given in the bottom square. So we're just going to read the steps. No numbers.
No numbers.
Estimated loss of annual income from external influences on subject improvements. Building capitalization rate from income approach.
We'll get to the math. Estimated loss of annual income from external influences.
Well, that's going to be something that's given because it's given in the paragraph above.
It is, but you're dividing that by the building capitalization rate. That's what you got to say. And then you come out. It says it down there. Income
I just haven't gotten there yet.
Okay, divided by building capitalization rate. You get your external obsolescence of improvement depreciation dollar amount. Okay, go ahead. Go ahead and reread it from the top. You got it.
Well, I don't really know what you want me to say. I'm really confused.
Okay, let me read it. Here, you have your estimated loss of annual income from external influences on subject improvements. Divide that by the capitalization rate, gives you the depreciated value for external obsolescence of improvement. This is like having a baby. Let's have a baby. Go.
External obsolescence can also be measured by analyzing paired sales. As an example, assume that a residence is experiencing significantly more traffic due to a recent zoning change on a nearby property. Sales of comparables that have recently sold are available. One adjacent to the subject property and one in the area not affected by the zoning change. The property adjacent to the subject property sold for $150,000 with a land value of $37,500. The property outside the area affected by the zoning change sold for $163,500 with a land value of $41,000. The value loss attributable to external obsolescence by the income loss method of $10,000 can then be calculated from these data as follows. Comparable sale 1, next to subject property and affected by increased traffic. $112,500. Sale price less current land value equals the sale price of improvement. The $150,000 less the $37,500. Oh, okay, which is the $112,500 for comparable sale 1.
Yeah, for the subtracted the land value to get the improvement.
Yes. So comparable sale 2 is not affected by traffic. The sale price less the current land value equals the sale price of the improvement. $163,500 less the $41,000, which is $122,500. All other things being equal, the difference between the two comparable sales would indicate the external obsolescence calculated from the paired sales. So the difference between the two is $10,000.
Yeah, it's like you're getting. We did this in market with those compared comparable sales. You're figuring out how much depreciation is what by the market, what the market's telling you. So that is for external obsolescence can be measured by analyzing paired sales. Okay, well that's a whole lot easier than that other one.
Mm-hmm.
But if you have sales, so I got it. Okay, all right, get it.
When a lump sum estimate of total depreciation is estimated through extraction, the depreciation due to external obsolescence must be allocated. Using the breakdown method of depreciation for the subject property, the appraiser must estimate the amount of physical deterioration and functional obsolescence present. As an example, consider a single-family residence with a reproduction cost estimated at $280,000. A comparable residence with similar depreciation recently sold for $250,000. Analysis of the market for site land sales has found the site value of a current comparable sale to be $50,000, resulting in the single-family improvement value of $200,000. Subtracting the sale price of the residence from the reproduction cost new yields the lump sum depreciation amount of $80,000. The curable physical deterioration estimated by cost to cure is $5,500, and incurable physical deterioration, both short and long-lived, is $8,500. The estimated functional obsolescence curable is $4,500, and the functional obsolescence incurable is $12,500. After the physical deterioration and functional obsolescence are summed, $31,000, and the total is subtracted from the lump sum estimate of total depreciation, the amount of external obsolescence by extraction is $49,000, as shown in Table 10.9. External obsolescence allocation of market extracted depreciation. Total cost new, $280,000. Sale price of comparable without land, $250,000 minus $50,000 equals $200,000. Subtract that from the total cost new, the total depreciation is $80,000. Allocation is physical deterioration curable, $5,500. Incurable, $8,500. Add those two together, and that's a total physical deterioration of $14,000. Then functional obsolescence curable is $4,500. Incurable is $12,500, and the total functional obsolescence becomes $17,000. So the total physical deterioration and functional obsolescence is to subtract $31,000, which is the $17,000 functional obsolescence plus the physical deterioration of $14,000. So you're going to subtract the $31,000 from the $80,000 of total depreciation to come at the external obsolescence by allocation amount of $49,000.
Come up to that table.
The appraiser using the breakdown method of calculating depreciation must realize sometimes that there is a thin line between curable physical deterioration and curable functional obsolescence. Also, the identification of a deficiency is incurable functional obsolescence, or as external obsolescence can sometimes be difficult, the identification of the cause of depreciation obviously determines the method of measurement. Significant errors can result from incorrect identification. The breakdown method requires considerable skill, especially as the improvement gets older. The appraiser must be careful to avoid depreciating improvement components twice. The following example illustrates estimating depreciation by the breakdown method. Illustration of the breakdown method. The subject property is a 12-year-old single-family residence in a neighborhood with a heterogeneous mix in terms of age and design type of residential dwelling units. The subject is located on the edge of the neighborhood, adjacent to a busy street. The residence is of frame construction, contains 1,560 square feet of living area, has no basement, but does have a one-car attached garage. The residence contains one 3-piece bath, and heat is provided with a forced air furnace. The improvements are in fairly good condition except for the interior and exterior walls, which need painting, and a back porch slab which needs replacing. Also, the kitchen floor covering needs to be replaced. The improvement has an age of 10 years. Market research reveals that residences similar to the subject property in this neighborhood are estimated to have a total useful life of 50 years. The roof cover, furnace, plumbing, and fixtures are 12 years old and have a total useful life of 20 years. The water heater and kitchen equipment are 12 years old and have a total useful life of 15 years. The electrical system is 10 years old and has a total useful life of 25 years. The sheet metal is 10 years old and has a total useful life of 20 years. The cost new for the residence is shown in Table 1010. Table 1010, Estimating Residence Cost New. Excavation and backfill, $2,000. Iron and steel, $2,600. Footings, piers, foundations, $14,000. Rough-in framing, $60,000. Concrete floor and slabs, $4,800. Exterior siding, $9,200. Finish millwork, $25,600. Lathe and plaster, $22,400. Finish flooring, hardwood, $8,800. Kitchen floor covering, $2,800. Roof covering, $8,000. Plumbing, piping only, $10,400. Plumbing fixtures, $11,200. Water heater, $1,100. Insulation, $3,000. Electrical, $10,000. Furnace, $11,200. Sheet metal, flashing gutters, downspouts, $2,600. Painting exterior, $5,600. Painting interior, $10,800. Hardware, $1,200. Kitchen equipment, $6,800. Total estimated cost new, $234,000. $234,100. Wow.
And you're an accountant.
And that has nothing to do with it. The total cost new is $234,100.
We get that number by summing up all those items. Okay.
Applying the breakdown method, the appraiser must first identify curable items. The cost to cure is the measure of depreciation. The analysis is shown in Table 1011. Table 1011, Curable Physical Deterioration, Deferred Maintenance. Item, painting exterior and interior, cost new, $16,400. Cost to cure, $17,000. Item, replacing kitchen floor covering, cost new, $2,800. Cost to cure, $3,000. Replacing back porch slab, cost new, $5,600. Cost to cure, $6,000. Total curable depreciation, cost new, $24,800. Cost to cure, $26,000. Next, the incurable short-lived items must be depreciated. Depreciation is the result of applying the age-life method to cost new for these items. This is illustrated in Table 1012. Table 1012, incurable physical deterioration, short-lived. Item, roof covering, cost new, $8,000, actual age, 12, total useful life, 20, ratio, 12 to 20.
12 divided by 20.
12 divided by 20. Depreciation, 60,000.
60%.
60%.
I think 12 divided by 20 equals 60%.
Yes. Incurable physical deterioration, short-lived, $4,800. Item, water heater, $1,100. Actual age, 12. Total useful life, 15. Ratio, 12 divided by 15. Depreciation, 80%. Incurable physical deterioration, short-lived, $880.
So that was...
Plumbing fixtures, cost new, $11,200. Actual age, 12 years. Total useful life, 20 years. Ratio, 12 divided by 20. Depreciation, 60%. Incurable physical deterioration, short-lived, $6,720.
So you're multiplying the cost new by the calculated depreciation to get the incurable physical short-lived item amount of depreciation. You can skip on down.
Skip on down.
Yeah.
And then they add up the total for incurable physical deterioration, short-lived.
Yeah.
Because we're going to use those numbers here in a minute.
Yeah.
The appraiser must then calculate the depreciation allowance for the incurable long-lived items using the age-life method. This is illustrated below. Cost new, $234,100. I'm going to have a problem with that one.
From the chart above.
From the chart above.
That's the sum of...
It's the sum. It's from Table 1010, estimating cost new.
Yeah. It's the sum of all the replacement cost new of all the parts.
Yes. Less the cost new of curable deterioration items, $24,800. That is from Table 1011. Incurable physical deterioration short-lived items is $50,900. That is from Table 1012, the incurable physical deterioration short-lived table. And you add those numbers together to get the cost new of long-lived items, which is $75,700, which you're going to subtract from the cost new amount. So $234,100 less the $75,700 gives total cost new of long-lived items $158,400. Actual age is 10 years. Total useful life is 50 years. So the ratio applied to the cost is 10 divided by 50. So the total incurable physical deterioration long-lived is 20%. So you multiply the 20% to the $158,400 to come up with a total incurable physical deterioration long-lived amount of $31,680. Once the incurable long-lived deterioration has been calculated, the total amount of physical deterioration can be determined as illustrated below. Curable physical deterioration, deferred maintenance, incurable, $26,000. That amount is coming from Table 1011.
In the which column?
The cost to cure column.
Yeah, that's important.
And then incurable physical deterioration short-lived is $29,860, which is coming from Table 1012, the incurable physical deterioration short-lived column. And the incurable physical deterioration long-lived is $31,680, which is coming from the calculated box at the bottom of page 296, the total amount that we figured out from all of our previous math calculations.
Ciphering.
So we're going to add all of those numbers up, the 26,000, 29,860, and 31,680, for a total physical deterioration of $87,540. Curable functional obsolescence deficiency. By current standards, this residence suffers a deficiency because it has only one bathroom. New, similar houses in the area are constructed with 1.5 baths, complete bath and powder room. The cost of building a powder room to the subject property is $14,800. If the powder room had been included in the house when it was built 12 years ago, the estimated cost new of the date of appraisal would be $13,200. In addition of the powder room would increase the market value of the residence by $18,000. Because the cost to cure is less than the value added, the item is considered curable. By using the functional obsolescence grid, the allowance for this functional item is calculated as follows. Cost of existing item, 0. Less any depreciation already charged, 0. Added to the cost to cure all costs is $14,800, or the value loss, which is 0, less the cost if installed new, $13,200. The functional obsolescence curable is then $1,600. Incurable functional obsolescence. The subject has a slab foundation instead of a full basement. This is a deficiency in relation to similar properties. Analysis of similar properties indicates that the properties with full basements rent for $1,600 per month, whereas the subject property, which has no basement, rents for $1,450 per month. Market analysis indicates a GRM of 100 has been derived for this type of property. Since the cost to add a basement would not result in a corresponding increase in the property's value, the functional obsolescence is incurable. Multiplying the rent loss of $150, was that correct? I turned the page too soon.
Yeah. Per month.
Multiplying the rent loss of $150, the $1,600 minus the $1,400,
$1,600 for a month for properties with a basement, minus the $1,450 a month for properties with a slab.
Are they per month?
Yeah.
That's where I've got myself confused in my head.
Yeah.
Okay, so multiplying the rent loss of $150 per month, which is the $1,600 minus the $1,450 by 100, which is the GRM for the subject property, results in a value loss of $15,000. Calculating the allowance for this deficiency is as follows. Cost of existing item, 0, less any depreciation already charged, 0, added to the cost to cure all costs, 0, or add the value loss, which is the $15,000 you're going to add, or positive, it's plus.
Yeah, you're not really adding, it's just a positive.
Yeah, so less cost if installed new is 0. So your functional obsolescence incurable is the $15,000.
Believe it or not.
You understand that?
I worked for, I'm kind of understanding it, sort of. But a guy I worked for had a house in Midland, 2-story house, and the retard dug a basement in the house. He did this. He dug it in there, but he's a millionaire.
Oh.
So.
But why?
Because he wanted a basement.
Because he's a dork.
Yeah.
Anyway. External obsolescence. The subject residence is adjacent to a busy street. This causes the subject to suffer an additional amount of rent loss. Compared to similar properties that are not adjacent to a busy street, the rent loss is $100 per month. Comparable properties in this neighborhood have a land to improvement ratio of 1 to 4, as does the subject property. The amount of external obsolescence is computed as follows. Estimated monthly rent loss of subject affected by property, $100. Estimated monthly rent loss multiplied by the GRM, and that is, the GRM is figured by the $100 by 100 GRM, which is $10,000. The ratio of land to improvement is equal to 1 to 4. The land is equal to 20%, which is 1 divided by 5. The improvement is equal to 80%, which is 4 divided by 5. And they're multiplying that 0.80 by the 10,000 to get
80%.
to come up with the external obsolescence of $8,000. Is that correct? Okay. Total depreciation by breakdown method. A compilation of the data computed above for estimating depreciation of the subject property is shown in Table 10.3. Table 10.13, measuring depreciation by breakdown method. Physical deterioration, curable subtotal is $26,000. Incurable short-lived is $29,860. Incurable long-lived is $31,680. They add all of those up for total physical deterioration of $87,540. For functional obsolescence, curable deficiency addition subtotal is $1,600. Incurable deficiency is $15,000. Add those together for a total functional obsolescence of $16,600. So then the third part, which is the external obsolescence, which is $8,000, which we just figured out. So your total depreciation of that single family dwelling is $112,140. I don't know why I'm doing that tonight. Good grief. So you add the $87,540 plus the $16,600 plus the $8,000, giving $112,140 total depreciation.
Hence the name of the breakdown method. You break down every form of depreciation of every category of depreciation: physical, functional, curable and incurable, and external obsolescence depreciation. And you're calculating those numbers. I see what they're doing in this chapter, or this section. They are trying to. They did all that long, and then now they're summing it all up in this little section right here. Okay, go ahead.
The breakdown method is one of the most complete and detailed ways to handle depreciation. However, it is so time-consuming that appraisers rarely use it except in the defense of appeals. However, appraisers should master the method because it provides a basic understanding of the many forms and causes of depreciation.
Or it might show up on a test.
An example of the final result obtained in determining market value by using the breakdown method is as follows. Estimate land site value $30,000. Estimate cost new $234,100. Estimate depreciation $112,140. So you're going to subtract
the depreciation amount this time.
The depreciation. So, but you're going to add the land value and the cost new together, and then subtract out the $112,140. Is that correct?
What? Say that again.
You're going
No. Let me read it. You estimate the land value at $30,000. That they're listing the 6 steps to the cost approach.
Okay.
Here, so you do that first. And in this case, in this example, this long ass example, we have 30,000 for the land value.
But it's not included.
It's not included yet.
Okay, it's just listed.
You list it and then add it back in at the end.
Okay.
You want to read?
Yeah, I've got where we're going now, but I don't.
You're gonna be able to do this. You're gonna come do this cross section for me.
No, I'm not either. Okay, so the estimate land value site is $30,000. We're gonna pin that right over here. So estimate cost new is the $234,100. Subtract from that the estimate depreciation, which is $112,140. So that equals the depreciated improvement value of $121,960. Then depreciated value of accessory and site improvements, which is 0.
You don't have any.
So you're going to add back in the land site value, which is $30,000, and you're going to get, that gives you in the market value by cost approach of $151,960.